Hi everyone, I'm Shi Song. I'm Associate Professor of Sociology and Demography at UPenn. So my talk today is on how to study multi-generational social mobility from our demographic approach. I understand that a lot of you probably are not demographers, but a lot of my work is to try to convince people that social mobility is a part of demography. And I have started to propose sessions at our PAA, the annual meeting of the Population Association of America. And first they got rejected, but in recent years, people started to include sessions on social mobility in the population community. So I would like to start my talk with some of the basics, but I didn't know that Stephen and our Esfandier already provided a lot of the background information about the social mobility, because originally I thought that, well, some of the audiences may not be social mobility experts. But because of my background in sociology, so I would like to start with some of the literatures in my own field. So traditionally, sociologists study social mobility using mobility tables, which was considered as one of the signature contributions of sociology over the last half century. And people typically only focus on two generations, measuring their socioeconomic status in terms of, say, occupation, income, or levels of education, or in recent years, in terms of their regions or neighborhood or places. And for most of the studies, they just focus on the overall correlations between parents and offspring. But in recent years, because of the development of causal inferences, people also started to think about what are the mechanisms that help us to understand how one generation influences the next generation. So here are just some very basic ideas of the social mobility table. I'll go very quickly. This is just to use one of the examples, using income quintiles, because in sociology, people like to study occupations, but because today we have many economists, so I use incomes, as I think income mobility is more popular among economists. So overall, we divide each generation into 5 equally sized income quintiles, and we focus on mostly those diagonals. The mobility table is another way of presenting just our transition matrix, as Stephen already described earlier. So for the diagonal cells, that just tells us the number of our offspring who stay in the same social class or income class as their parents. And we can convert the frequencies into mobility probabilities. This is just based on a row transition matrix. So you present parents as the rows and offspring as the columns, and the marginals add up to 1 in terms of the row marginals. That tells us the probability that are conditional on parents' socioeconomic status. What's the probability that an offspring will stay in the same social class as his or her parent, or will flow to a different social class? And I realized that in recent years, so for example, Rajchetty, they also focus on this specific column, considering the probability of flowing into the highest social class. So he calls this a child chance of success. So namely the probability that a child will reach the top quintile of the income distribution. So this is just another way to understand how, based on this very simple contingency table, we can understand the relationships between our 2 generations. So the mobility table has been used probably more than 100 years, and it has been criticized from the very beginning. So here I just quote one of the critics from Otis Dudley Duncan, who is a famous sociologist and also known by his work on social mobility. So he cautioned mobility researchers that what is fundamental is the process by which occupation structures are transformed, namely the succession of cohorts and the intra-cohort net mobility are not simply translatable into the process one may observe in a so-called intergenerational occupational mobility table. So Duncan didn't explicitly use the word demography, but his critique actually points to the importance of understanding population dynamics or the renewal of population by thinking about not only just social mobility across generations, but also all the demographic processes that govern the transmission from one generation to the next generation. So more specifically, think of this as our traditional view of studying our intergenerational mobility. And this is the problem become even more serious when we consider multiple generations. We basically are only focused on those families who have children and then link them across generations and measuring their socioeconomic status. So here I use two social classes indicated by different colors. But if we take a demographic perspective, we will see that not all the families have children. So if we just focus on our social mobility based on mobility tables, we basically exclude all those parents or earlier ancestors who don't have children or grandchildren. And second of all, we also our sample also overrepresent those families who have more children. And third, the sample includes our parents who are born into different birth cohorts and who also vary in their childbearing ages. So essentially, what I try to advocate is to understand intergenerational mobility, especially over multiple generations, by taking this demographic perspective, combining the unequal fertility, mortality, or selective mating, and our migration or other demographic processes into our understanding of our social mobility processes, especially over a long term. So this is just to build on some of the discussions Stephen mentioned earlier about Markov chain models and its application to studying social mobility. So it's very easy to see that essentially we can project each generation using a Markov chain process. So here I indicate the offspring generation by S and the parent generation by F. And it's only governed by this mobility component P. And we can, of course, present it in a matrix form. So this is a traditional way when we ignore the demographic component. So for today, I'm going to show you how we can expand it. But overall, we know that in the long run, so the Markov chain will converge to its equilibrium, and it's completely governed by this transition matrix. And eventually, all the families will forget its past. So no matter whether you start from a high social class or a low social class, so all the families will converge to the same distribution of their social, their descendants after long enough time of generations of social mobility. But things will be, different if we consider demography. So here I borrow some of the critiques by Thomas Parham, who graduate from U Chicago sociology, and I think this derives part from his dissertation. He at least listed 4 critiques of the traditional Markov chain mobility models. So first of all, we know there is no demography, and we typically assume it's a Markov chain process. Basically, each generation's socioeconomic status is only governed by the parent generation, and we ignore the influences of grandparents, great-grandparents, or even remote ancestors who may have a lingering influence on their descendants' socioeconomic attainment. And the third is, for most of the empirical studies, they typically just focus on a single sex, typically males, as we know are, for example, for income or occupations for females in traditional societies are harder to measure. And finally is, for most studies, they assume a single mobility regime in a society. So you think, well, are people born into different subpopulations will follow exactly the same mobility rules. But actually, this may not be the case in some societies. For example, are in historical China, in a patriarchal society. So some of the social classes are totally separated, and there is no chance to are upwardly mobile from one class to the other. So I see here is Larry raised his hand.
Yes, I just have a question. So when you're the Markov chain that you introduced a couple of slides back, this is not the mobility table, is it? Or the normalized mobility table, is it?
Well, so the P here, the mobility, so basically conditional on the generation one's socioeconomic status, what's the probability that the offspring will achieve a certain social class. This is based on the mobility table. You can convert the mobility table into a transition matrix.
Okay, good. All right, that's what I wanted to know. I have some questions about that, but I'll save them for later.
Sounds good. Okay, so what I'm going to do today is to propose some of the models that can help us to address all these critiques. So for the sake of time, I won't be able to elaborate on all different aspects of these models. I will try to focus on the basic ones. But overall, I propose this model called the joint demography social mobility model that will allow us to combine demographic processes and social mobility processes to jointly predict our population renewal or to understand this multi-generational processes of families reproduction. And I will also relax some of the assumptions of the Markov chain property by incorporating influences of grandparents, great-grandparents, and earlier generations. And I will extend it to a two-sex approach that take into account the dynamics of males and females in a population in terms of how they form unions and how they will influence the social makeup of the next generation, as well as how they are jointly shape the mobility chances of their offspring. And for the last part, I will consider some of the heterogeneous mobility regimes to relax the homogeneity assumption, so that we will see for some societies, as I mentioned, the historical China, or say in India, if some of the castes, there is no way for people to change from one caste to another. So for those completely segregated subpopulations, so what are the models we can propose to understand their social mobility? So first, well, I will describe my model. I will begin with a very simple model. The only difference between this model and the traditional Markov chain model is that I add this term called the reproduction term into this. I highlighted as the expected number of offspring born to a man in class I. So that we are not just considering our probability distribution of the next generation, but just in terms of numbers. So we change our probabilistic view to a distributional view, so that here the S will represent the number of sons. So here, say we just use a one-sex model. in different social classes rather than the proportion of sons in different social classes. So that we can represent this model in the matrix form by combining the reproduction term and the mobility term. And well, we can further relax the Markov property by assuming that both the fertility of a man in terms of the number of sons he will produce, as well as the social mobility probability of his sons depends on not only this man's own social economic status, but also the grandfather's social economic status. So this is a recursive model, and we can do this to predict the distributions of his sons and his grandsons. But more generally, we can even assume that a person's socioeconomic status depends on all the prior generations, not only depend on the parent generation. Let me see if I have a slide on that. Well, so I didn't include all the proofs here, but I can send you my working paper, which will show that once you add this demographic component into the Markov chain model, so we will no longer observe this convergence to this equilibrium that is independent of the original status. So essentially the number of offspring or descendants a family will reproduce depends on their initial status, depends on where they start, whether they start from a rich family or whether they start with a poor family. And this, well, this process is also governed by the largest eigenvalues of this the initial vector of the distribution of the social status. But I will ignore that. Here, I want to show you, based on this model, how can we compare the social mobility effect relative to demography effect to see which plays a more important role in shaping multi-generational processes of family social reproduction. So I will use a very simple example here. Assume that we define the comparative advantage of a parent in high social status over low social status in producing high social status offspring, as we just based on this difference measure by using, say, a parent starting with high social status, the number of his offspring in high social status minus the number of high social status sons that are coming from a low social status family. And we can further, extend it to multiple generations. Then there are two ways to define it. So here I consider the net. This is called the social reproduction effects. Some people don't quite like the term because they think it sounds too Marxism. So I will just use this here. The net effect means that, well, if a grandparent is in a high social status rather than in a low social status, so what will be the number of grandchildren in high social status if we conditional on the parent's social status? Whereas the total social reproduction effects measures the comparative advantage of having a high status versus a low status grandfather. So if we just regardless of the parent's social status. So the first is more similar to our conditional probability, and the second, the total effect, is similar to our unconditional probability. The only difference is that now I measure it in terms of numbers rather than probabilities. And then we can decompose the social economic, the social reproduction effects into the demography and the mobility effects. Here I use a Kitagawa decomposition method. So she is actually a our sociologist, was at the University of Chicago, and many people thought that she's a minority woman, but no, she's a white woman. And she used to be a chair of the sociology department. So her picture is still in the sociology's main office. But it's a very simple decomposition method. The demography effect tells us, so the effect that can be attributed to difference in reproduction or the number of children measured by fertility. And the morbidity effect measures the difference caused by the morbidity probabilities while fixing the reproduction for different families as a mean of those two groups. And then here are some of the demographic work that considers how we can extend this to multiple rates. So one of the famous methods is called the Dasguptas decomposition method for the differences between 3 or more rates. So think about if we want to understand the difference in the crude birth rates between US and Germany. And we can decompose it into 3 components as differences in the proportion of women in those 2 populations, and then the proportion of childbearing women in those 2 populations, and further, so among those childbearing women, what's the differences in the fertility rates between those 2 populations. So here I adapt this method and then generalize it to our multiple rates so that we can decompose the difference between 2 rates into multiple components. So here, if we have 3, if each measure is considered as a product of 3 rates, then we can decompose it into the differences in the rate A, rate B, and rate C. So this is a basic idea of this method, but what I did is to apply it to here the total social reproduction effects of our grandparents, say. So for each family, the total number of grandchildren depends on the reproduction or fertility of the grandparent generation, and then the morbidity from the grandparent generation to the parent generation, and then the fertility component of the parent generation, and finally the morbidity component, or measuring the morbidity probability from the parent generation to the offspring generation or the 3rd generation. So by applying this revised Dasguptas decomposition method, we can then decompose the total social reproduction effects into the demography and the mobility effect that operates through each of the generation. And the 3rd component is that, well, as I mentioned earlier, this one-sex approach may not be enough. At least I can think of 3 reasons. The first of all is that, especially in modern societies, our mothers and maternal ancestors may influence individuals' socioeconomic status. So in some of the ancient societies, for example, in ancient China or in the Jewish population, the priest, this status can only be passed down from fathers to sons. So in those cases, when the transmission of socioeconomic characteristics is sex-linked, we can adopt a one-sex approach. But in most cases, if the social status is jointly determined by both parents or both sides, the paternal and maternal sides of the families, then we may consider a 2-sex approach. And the second reason is that for the fertility and the morbidity probabilities that I have discussed in the joint demography and social mobility model, it may vary by gender. So if you separate males and females, this is a very famous cause, the 2-sex problem. And sometimes you may get inconsistent predictions of a population growth if you don't consider the interactions between males and females, but try to do the projection based on male rates or female rates alone. And finally, we all know that authoritative mating is a very important process that shows the interactions between the males and females population and how they form marriages and how they are. The formation of marriages also determines the social background of the next generation. So here are many different two-sex models that has been proposed by demographers, biologists, evolutionary geneticists, as well as ecologists. So for today, I'm going to show you this. I adapted from Robert Pollack because he's an economist. So his work on the two-sex demographic models. So essentially, we can modify this multi-generational models by introducing the number of marriages. So we add another component into the model. And if we can determine the number of marriages in a population, this is to assume that, well, the fertility can only occur within marriages. But of course, we can relax this by considering the number of unions or informal unions rather than formal marriages. And then to, based on that, to predict the number of males and females that form different types of unions, and then to use their socioeconomic information to predict the social mobility of their offspring. So here we need to have two separate models, one for daughters and another for sons. And here I use the authoritative mating rule proposed by Pollack based on the harmonic mating rule, but I have also considered two other hypothetical rules based on random mating or endogamous mating, meaning that people only mate within their own socioeconomic status. As I'm running out of time, I will just skip this discussion on heterogeneous mobility regimes, but it builds on some of the earlier work of Burton Singer and Seymour, Spielerman, and others. But I have further differentiated at least the three different types of heterogeneity that are either associated with individuals' own socioeconomic status or characteristics, or associated with time, or associated with this segregated subpopulation mobility regimes. Because I want to spend some time to show you some empirical illustrations of the method so that you will be able to see how it can really show us different conclusions about the multi-generational processes when we build the demography into social mobility. So I'm using both historical data and contemporary data. So the historical data are just from some of my earlier works that linked historical US censuses across different census years. So I link it every 30 years. For example, in 1850, we observe a little kid living with his parents so that we know his parents' socioeconomic status. And then after 30 years, we try to find the same kid, now an adult, in a later census. And then we link it so that we know both his own socioeconomic status as well as his childhood or family background. And for our contemporary data, I use the panel study of income dynamics, which has been used widely in previous studies on intergenerational social mobility. So here are some mobility tables. I try to present it in terms of the heat maps. As you will see that for the linked historical census shows a period between 1850 to 1930. I don't know whether the labels are too small, but here we consider 5 classes from upper non-manual, lower non-manual, or upper manual, lower manual, and farming. So for the historical data, we see a very strong persistence along the diagonals, means that for most people, they just stay in the same social class as their parents. Whereas in contemporary years, especially for the farming population, now most of them actually are moving to lower manual or upper manual occupations, and very few of them stay in the same farming occupation as their parents. So intergenerational mobility in the United States has changed dramatically over the past 150 years. So now I'm going to apply those different mobility regimes to show you how it can influence our understanding of the social reproduction. So in terms of the number of offspring in different social economic classes. So here, of course, we need this reproduction or fertility component. So overall, the reproduction rate has dropped dramatically in the United States from the 19th century to the present, but there's a pattern in terms of the gradients among different occupational classes didn't change that much. So for example, here farmers used to produce on average 3 sons. So but now they only produce about 1.5 sons. So in terms of fertility, we can roughly multiply that by 2.
Professor, you have about 3 minutes left.
Okay. Okay, so I will try to wrap this up to show you first the total social reproduction effects for the historical data and the contemporary data. They are very similar and are in terms of the effects of parents, but for the grandparents, well, the historical effects of grandparents are much bigger than the grandparents' effects for the contemporary periods. So that means the influence of grandparents on their grandchildren has declined over time. If we decompose this into demography effect and mobility effect, so for the historical period, so demography explains more than 70% of, the mobility explains more than 70% of the effects, but now it explains even more. So the indication here is that our mobility, so most of the multi-generational influences works through mobility rather than demography because of the demographic transitions happened in the US over the past century. And further, we can decompose it into the demography and mobility effects via different generations. So here I just want to highlight a few numbers for the historical period. So demography effect via the grandparents' generation is particularly important as it explains more than 30% of the total effects. But in contemporary periods, the effects of demography becomes very small. So most of the influences works through mobility via the transmission of social status from grandparents to parents and parents to grandchildren. I think I will skip some of this as I'm running out of time, but what I want to highlight is that when we consider different mating rules and the assortative mating that we observed in a population, is actually the effect is bounded by the other mating rules. So for random mating, it's a mechanism that can actually reduce the intergenerational reproduction of inequality, whereas endogamous mating can reinforce the inequality. And what we observe is typically a number in between. So if we consider other types of mating rules, it can give us a bound, the upper and lower bounds of this multi-generational effects. So that's something I hope future studies can also illustrate those rather than give us just a single number without showing us where the bounds are. Let me just to quickly summarize. The first is, well, I try to show you some simple models for today that jointly consider social mobility and demography to understanding multi-generational social mobility processes. And I changed from this purely probabilistic view to this distributional view by considering the number of children and our descendants in different social classes, not just in terms of the probabilities or proportions. And this model can help us to better understand the interactions between population processes or population renewal and social mobility, and can help us better understand our past and also to forecast the trends in the future. So I will stop here.
Thanks so much. I'm going to think I will take advantage of my position and ask you a couple of questions.
Sure.
One is whether you've done these calculations by race.
That's a very good point. Yes, I did it in the paper, but I didn't show you here. And of course, the racial differences in the fertility are very big. So you will see that demography actually plays an even bigger role among some of the minority groups, African Americans or Hispanics than whites.
Yeah, so my interest was a little bit more on the multi-generational dimension of that. One of the things I've been horrified by whenever I see occupational mobility, when I've seen occupational mobility tables by race, is the high conditional probability that the children of professional and managerial workers are in less skilled positions. And so I guess I was interested in knowing whether if conditioning, does something qualitatively change if you condition on more than one generation? A little bit of what I'm asking is this capacity of family dynasties to build some sort of, I'll say momentum for the lack of a more precise term,
yeah,
that moves the descendants away from lower.
That's true. Yeah. Yeah, for two reasons. I didn't show the results here. So first of all, because of our intermarriages between race. So it's very hard, especially over multiple generations, to follow a person say this family is completely belong to this single race category. And second is basically the data limitation because of especially the linked historical data. We used our family names to do the linkage. And of course, for our many ethnic minorities, they change their family names. So the sample may not be representative. But another point is, well, some of the racial groups may be underrepresented in the professional or some of the high status occupations. Thanks, Stephen.
Thanks. Are there other questions or comments?
Yes, please. Stephen Jenkins.
Yes, please.
Please, thanks. That was a really cool paper. I'm really interested to see you bring demography back in. Family size matters, men and women, it matters. I mean, another thing that has been picked up in the past related to the two things is that different inheritance rules across different countries begin to play a role as well, ranging from primogeniture to equal sharing. Maybe not so important in the context, but maybe over the US history that you're thinking about. I just want to make a second observation, which is to make the link between the sociologist's approach and the economist's approach, is just to observe that well before Becker and Tomes overwhelmed everybody's reference lists, there were economists out there who were actually working through the implications of some of the demography that you're talking about. In particular, people like James Mead, with papers on the inheritance of inequality. Alan Blinder, believe it or not, yes, 1973 had a model with demography in it and looking at across generations, and also the late great Tony Atkinson around the beginning of the 80s.
Yeah.
Picking up all these things about the effects of differential family size, who marries whom, and how they interact with inheritance rules. And you can, making a link with Essie's paper, what's nice about some of those models is that you can, although people were looking at them at the implications of inequality, you can actually use exactly the same models to look at the implications for a simple summary statistic like the IgE, intergenerational elasticity.
That's a great point. So I'm going to incorporate those into my paper. And in fact, for my models are built upon some of the earlier models proposed by an Israeli sociologist, Judah Matras, in the 1960s. So typically, I find sociologists like to only focus on the work done by sociologists in the US, but it would be great to incorporate all those different traditions of literature that have addressed this common topic.
You sound as bad as economists.
Yeah, we're not talking to them though. Yeah.
Stephen, can I go?
Oh, yeah, people should just ask questions.
Okay.
Remember, I believe in spontaneous order.
G, thank you for that very very interesting paper. So on these transition probabilities, when one reports them, there is by implication the picture of different outcomes for different groups and different parts of distribution, professions, or demographics. So the policymaker, if he were to respond to a picture, will have to worry about differential impacts of a policy on different demographics, right? So they want, for monitoring, they require some kind of summarizing these transition matrices. And going back to Hart and Praise and others, Sharrock's, there are summary measures of these transition matrices, which raise the same types of questions that I was alluding to about scalar measures, summary measures. One good news is that some of the measures I reported to you in terms of the actual mobility measures are sufficient statistics for these transition probabilities. So that's the good news. It's the opening to actually also find out that there are, in fact, welfare theoretic justifications for different measures of these transition matrices, the trace, the determinant, and all sorts of measures that have been proposed do have welfare theoretic justifications, which expose what they pick up and they don't. They're totally focused on transitions, not the characterizations of the distributions of outcomes. And so from that point of view, they share both the good and the bad with some of the measures that I spoke about. I think it's good to report both. One question I have for you is the decompositions you reported require a sort of assumption of independence between the outcomes whose probabilities you pick up and the demographics, and that's often not true. I would suggest. I'm not saying it's true, but these decompositions, if you think of some of the components, the demographic components, if they are not independent of the probabilities, then it's very difficult to monitor these over time to see what is happening. Independence becomes a very important requirement for these decompositions.
That's a good point. Yes. So for the decomposition method, even for the Kitagawa's method, there are other versions that try to include our interaction term. As earlier you mentioned, so Osaka, so blinder decomposition, they also have this interaction component. So for here, I assume that we can completely decompose it into our 3 or 4 components that work through mobility or demography through either of the generations, but of course, sometimes there may be overlaps. So that's a well-taken point.
So may I ask a question? So I guess I want to challenge you just a little bit. By the way, I really like to talk, and I think it's really important that we bring demography into the discussion again. That's the way I think to put it. But here's my question: if we think about income or occupation, or rather wealth, and or occupations, and if we think that the underlying data generating process is Markov, then the mobility probabilities that are constructed in these tables are going to be themselves random, and they won't typically evolve in a Markovian fashion. If the underlying Markov process is ergodic, they will be ergodic. The process of the probabilities will be ergodic. So there's something to be learned from them, but I would think 2 things. First, this must have some impact on how you would do inference with these things. And I'm wondering if you've thought about that. And then the second thing is that, so what will happen is that if these things are not Markov, even though the underlying data generating process were Markov, then if you look at, for example, the grandparent effect, that could just be an artifact of the missing information in some sense that's in the mobility probabilities, and not a real thing. On the other hand, of course, it could be that the underlying data generating process includes grandparents as well. So how do we know? How should we think about that?
Yeah, well, I think, well, both are wonderful comments. I didn't state my assumptions explicitly, so, but here I assume that the Markov chain, the transition matrix is regular. But as you mentioned, if it's not ergodic, so say if there are in some of my other work, for historical China, we observe those descendants of emperors and also descendants of slaves. So there is no chance for them to transit from one status to another status. In those cases, we need those models, as I mentioned very briefly, those heterogeneous models, or we need to study them separately. But I think there may be other ways to do this. Well, if you have some thoughts, I'm happy to hear some of your own ideas about how to extend the model.
I don't think I was quite clear, because I think what I meant to say that the thing that you were calling a transition probability is itself random, which is to say that next period, the realization of that might be different than it was the previous period. Not that when I should have not have brought up that stuff about ergodicity, because I didn't mean to say that there is a transition probability that is ergodic, right? What I meant to say was that the object that you were using and in some sense treating as a fixed thing is not fixed, it's random.
I see. Well, so yes, essentially this only shows the point estimates of the number of offspring and descendants in each of the social classes. And there are some other work that try to develop confidence intervals or the higher order summary statistics for those distributions of descendants. I think that will be really useful extensions. And your second point is about well, how do we know it's really the effects of grandparents, or we can just say observe parents and grandparents, but the effects of grandparents also subsumes the effects of all the prior generations, right? So that's I think you are thinking about it from more causal or identification perspective for us to, if we don't know the real data generating process, so how can we separate the effect of grandparents from great-grandparents or even earlier generations? I think, well, Stephen and I have talked about this, right? So he certainly has some ideas about how to do this. And I think that's also something I would be very interested in working on this. And our Jerry Behrman also sent us his paper, his working paper. He's also working on a related problem. And his argument is that we need at least 5 generation data to identify the effect of grandparents and 6 generations of data to identify effect of great-grandparents. So the basic point is that we need more data. So if only three generation data, we cannot identify the effects of grandparents. But thank you.